Okay, we're going to learn about the definition of the complex numbers. Complex numbers, okay? So complex numbers. Usually, complex numbers is divided into two small parts. Okay, it's a self-divided two small division or part. The first part is, as I've spoken to you, it will be real part. Okay, so real numbers. Second thing is the imaginary part, so which is called I. From now on, everyone, the letter representing the complex number is being used for C. Capital R, has been referred to the real numbers. Capital I is now being used for imaginary numbers. Okay, or sometimes I is being used to integers, but doesn't really matter. Okay, now what was the definition of the real numbers? Okay, so how do you know which is real numbers, which is imaginary numbers? Real numbers is real. Okay, what is real? When you square any real numbers, the result will come out as either positive or zero. So that's the definition of the real numbers. Whereas the property of the imaginary numbers is completely opposite. Okay, so if you square the imaginary number, it will come out as negative number. So that's where we have the formal definition of imaginary numbers and the complex numbers. Okay, you cannot be able to think about, oh, what is the number? To square it makes it negative. You possibly not be able to get it because we have been using real numbers only so far right now. So how we define the imaginary numbers? Okay, so it's not defined. We just describe. So what is the imaginary number? Okay, now we're going to define very unit imaginary number like this. Okay, if you square any unit imaginary number, it comes out as a negative one. So that's the unit imaginary number. So let's define like this. Okay, and from the definition, then a lot of other theories will come out to have a new, new theorem, new, expectation, new question. Okay, and then what you can do, it will also can be seen like I equals to square root negative 1. In about few years ago, you probably remember, okay, whatever number inside of the square root, okay, whatever the inside of square root, that square root, okay, the internal number of the square root must be positive or equal to 0. It can't be negative. Okay, so because that was a real number. Now we have defined another number which is called the imaginary number. That is the nature of the imaginary number, which is negative 1 of square root of the negative 1 is the I. That's how we define a very unit imaginary number. Okay, so that's where all of the idea is coming from. Okay, now how we can say, so these are quite simple. Well, real number is also part of the complex numbers. Okay, or imaginary number is also part of the complex numbers. So if you say only real number, we can call that is the complex numbers. If you have only imaginary numbers, we can also say, oh, that is the complex numbers. There's no problem. In other words, you can also consider like this form. Okay, say complex numbers is real number plus imaginary number, but imaginary number is been defined as I times real number. That's also quite possible. Okay, so there are a lot of different variation in defining the complex numbers, but this is just the start off. Okay, understand that, guys? Okay, next small bit that you have to understand is this one. So new function is not really a function, it's kind of acronym. Okay, so RE is referred as real number, okay, or real part. So how do you read this one is what is the real part of x plus yi? Okay, it's not difficult to understand, guys. That is the real part and this is the imaginary part. Make sure that is the real part, which we call x. Okay, x is the result of this function. Okay, for example, if you see real part of the 3 plus 4i is simply 3. Do you get it? So anyone can do this one. Okay, you pick up the real part, that's the answer. while as im, which is the first two letters of the imaginary numbers, is like this one. Okay, how do you read this? Imaginary part of this complex number, okay, it is y. You have to make sure not yi, okay, not yi. It must be y. Okay, the prerequisite of the complex numbers, there's an I, but these two numbers will be real numbers, as we did before, okay? How do you think about the example, everyone? We're going to use the same examples. The imaginary part of 3 plus 4i is just 4, make sure, not 4i. Understand it? I saw a lot of students confusing, 4i. They lost the mark from the exam. It's so sad. Okay, so I don't want it to happen for you. So just make sure it is 4, not 4i. Okay? Okay, so these are the very basic and the fundamentals of the complex numbers. Okay, so there are lots of other things that you need to learn, you need to cover to move on. However, this is the first step that you need to understand. Understand that, guys? Okay, let's go to the question now. Question 1, we're going to simplify I cube. Okay, so I cube, what is I cube? I cube equals to I times I times I. Okay, the cube is I times I times I. Cube is times, triple times. Now, what we need to do is, all of the questions that we are going to do is to use this feature. Okay, -1. So this is the stuff that we will need to use over all of the question. Okay, let's have a look this one. I cube equals to I squared plus times I. You get it? Okay. Now, what is the value of the I squared? Here. So that is -1. Okay? Write it like this. And then simplify like this. The answer is -I. Okay, you understand that? So just negative. Don't worry about what I is. Yeah, I is square root -1, but don't worry about too much for the time. Right now, we're gonna learn more and more. Throughout a lot of in the future videos. Okay, so that's the very first question. Let's look at the second part. Okay, so I power of 12. So I times for 12 times. How do you do? We still have to consider this important property, I square equals to -1. Thereafter, what you have to consider is consider how to extract 2 out of 12 by the use of the laws of indices. Can you imagine this? Okay, so this is the way you can make square, and another times 6. It'll eventually become 12. Okay, then what do you see? So I square equals to -1. Substitute in -1, 6. It's just a simple calculation. Okay, any student can do this. So -1 and even power, it will make positive. So simply 1. That's how you make it simplification. Do you understand that? Okay, that's the second part of the question. Okay, let's look at part C. Look at this one. Simplify I power of 999. Okay, what is the one? Okay, 999 is I times 999 times. I do not want you to times 999 times, but we can still use this property. How to use it? Okay, no matter what your question, look at the power. You try to make it an even power if it's possible, like this one. Okay, so I power of 998 times I is eventually 999. Okay, 999. Do you understand it? Okay, we have an even number. Then we can make like I square. Okay, now we are ready to use the I square. How do you do it? Okay, simply divide 998 divide 998 by 2. Okay, it will come out 999. Then we are happy to have I square within the bracket. Can you see this? Okay, then almost finished. Substitute -1 within the bracket, like this, and then what do you see? Okay, no matter what this number, okay, so we can recognize that is the other number. So all the power of -1 is simply -1. Can you see that? So you do not have to calculate 999 times, but we know how to do it, which is 90, -1 again. Okay, so I is there. Okay, I is keep on following that without having any working, because that is a imaginary number, and we are only working with the coefficient. So right, the answer is -I. Can you see? So it's so simple. Okay, so don't worry about. Okay, I just want you to give more confidence rather than complexity. Okay, so I'm pretty sure you guys feel it, you guys having a little better feeling. Complex number is not too hard. Okay, that's what I want you to get, guys. Question 2. Little more. Okay, little more than question 1. Okay, we define z, okay, complex number z, and another complex number called w. Okay, so two different complex numbers. And then we're going to simplify to z plus w. Well, guys, do you remember about the algebra? This is nothing but an algebra with a little more extra, which is called I squared equals to -1. This tells you everything about the complex number. Okay, let's substitute. Okay, so z equals to 2 minus I, no problem. W equals to 4 plus 2i, also no problem. Everyone expanded. Okay, so times to everyone, and then 4 plus 4 equals to 8. -2i plus 2i is 0. You can treat it I as a pronumeral, as usual in the past in the algebra question. Okay, so you can certainly do that. So the answer is just simply 8. Easy? Okay, so that's part A. Let's do part B. Part B is, okay, now we're going to multiply I to another complex number. Okay, so anyway, sub them in. So I times 2 minus I, okay, 2 minus I is sub in here. W is 4 plus 2i, is there. Now, expanded. Everyone expanded. Okay, so I times 2 becomes 2i, I times I squared, I becomes I squared, like this one. Okay, and this is the usual expansion. Now, what do you see? You are seeing I squared, then you can solve this real number, which is -1. Okay, like this one. So what is here? That is -1. So that becomes +1. Okay, so +1 minus 12 becomes -11. It's simple numerics. Okay, simple numerical calculation. And then 2i minus 6i is now minus 4i. So that's the final answer. How simple that is. Yeah, you can treat the I as a usual pronumerals or variables, but only new thing is I squared is -1. Okay. Okay, next question, part C, z times w. Okay, z times w. Multiply those two. Well, if you multiply those two, do as usual. Okay, as usual as you did in the past. So this times this, this times this, this times this, and this times this. Within multiple of time of this one. Okay, so result of that simple expansion will be this one. Okay, again, same story. I squared is -1 again. Okay, that's all you need to substitute. So -2 times -1 becomes +2. All you need to do is just simplify as part of the algebraic calculation. 10. Okay, if you multiply two complex number, it comes as just a real number. It's just normal. Okay, that's question 2. Okay, part D, z squared. Okay, z squared. Just use z squared. Use the formula. Okay, so what was the formula? A minus b squared. So a squared minus 2ab plus b squared. Can you remember this? Okay, it's a very easy thing to do. Now, what's happening here? You just expand it as part of this rule. Okay, again, I squared equals to -1. Substitute in. Okay, then negative 1. So 4 minus 1 becomes 3. So 3 plus 4i is the final answer. Okay? How do you think? Do you feel scary? I don't think anyone gets scary because that's a simple algebra. Okay, so nothing special. It's just I squared equals negative 1 that resolves most of the questions for you. Okay? Okay, question 3. Okay, now we're going to practice more with regard to the RE and IM functions. Still the same thing. As long as you can simplify, then take out the real part or take out the imaginary part. That's extra. Okay, z plus w. Okay, simplify what z plus w is. Substitute. Okay, so z plus w. So 2 plus 1, 3. Minus 3i plus I, which is negative 2i, like this. So what is the real part? 3 is the real part. Write it. That's how you do. Okay, so too easy. Always try to consider which is real part, which is the imaginary part. Okay. Okay, part B. We're gonna find out the imaginary part of iz. Okay. We're gonna calculate what iz is now. I times z equals to, okay, I times z, so I here, okay, like this. Again, I square equals to negative 1, like this. So that becomes 3. So what's the imaginary part? So this is imaginary part, this is the real part. So we simply pick 2, okay? So that's the real part of the complex number. Make sense, guys? Okay. Part C, all right. We need to multiply z times w first. Okay, expand them. Anyone can do this. Expand. Make sure that is negative 1. Okay, so that's negative 1. So 2 plus 3 becomes 5. Okay, and the real part, the 5 is a real part of the complex number. Can you see? The answer is 5. No problem at all. Okay. Okay, question 4. How do you handle question 4? Is solve this one in complex number fields. Okay. Well, you guys will be seeing what will happen this one, but if you had had this question before, not part of the complex number, the answer was undefined. You will see why. Okay? But we can still continue because we're going to work on the complex number field. Okay. Right, how do you do it? You have a few options. You can use the quadratic formula, or you can use the completing the square, or any simpler method. That's fine. As long as you can think whichever the easier, you can do anything. But today we're going to use the quadratic formula. Okay, like this one. So that's the result of the quadratic formula. Remember, 2a minus b plus a minus b squared minus 4ac. Can you see that? Now, simplify this one. So 4 minus 12 is negative 8. Okay, this is why, okay, this question has undefined solution, or has undefined or no solution, because we were dedicated to solve the equation only in the real number. But we already expanded to the complex number field. We are still okay to continue. Can you see this? By the use of negative 1 equals to I. So we have a new number from today. We can use I. Okay, guys? Okay, again, we can simplify. Okay, so 8 equals to 4 times 2. Okay, 8 equals 4 times 2. Like this one, 8 equals to 4 times 2, which is 2 square root 2. Can you see? So that 8 becomes 2 times square root 2. Negative 1 is there without having any touched. Can you see? So what was it? So when you do this third, okay, guys, a times b, okay, this is a third formula you probably learn in either in year 9 and year 10, which is you call square root a times b equals to a times square root of b. You can separate the third. Can you remember? So we can do the same thing here, like this. So square root of 2 and negative 1 is being separated. Can you see this? Okay, in here, what you want to do, your first step is to see, we can change this is I. Another one, we can cancel them. Okay, so that we can simplify as much as we can. Okay, we jump on here. Okay, the second step that I told you, square root of -1 is becoming I. Then we can divide everything by 2. It will be -1 plus minus square root of 2i. Make sure the I is the outside of the square root. Okay, so now it is different. 2i. So that is different from this. Make sure I is outside. If you're not sure, okay, if not that comfortable in writing the answer, I suggest you to write this one. This is clear. So I is outside. But if you write like this, I may be inside. Okay, or if you write 2, a little space I, this is also fine. Okay, so this is how you do. Remember, as long as the question asks you to solve in the complex number field, or the question may say in C, then you can keep on going. Even there's a negative number within the square roots, is completely fine. Okay, so this is the first quadratic equation which is being involved with the complex number. So answer is coming out as a complex number. Okay, so that was the question 4. Let's move on question 5 now. Question 5. Okay, same question, but this is a cubic. Okay, this is a cubic equation. How do you do? Well, this cubic equation is like x cubed plus 2 cubed. So we can use the formula. Remember that? So that is x plus 2, x squared minus 2x plus 2 squared. Okay? I'm sure you can remember this one. So we are going to apply this formula to the, well, not the formula, we just did it. Okay? We just write again over here. So this is how you simplify. Okay? In this simplification, we have 2 separate sets of equation. Okay, so the first part and the second part. Well, that's the real number. So not much thing to do. Just leave it alone. This part, yes, we still have to solve them. Okay, solve this quadratic equation. How do you do it? I recommend you to use the quadratic formula as we did in the question 4. Okay, use the formula, everyone. Same thing. Okay, it comes out 4 minus 16. What is it? It is negative 12. Okay, so negative 12. How do you do? Negative 12 equals to, so 4 times 3 times negative 1. Can you see? And that becomes, the 4 becomes 2 outside of the square root. Then root 3. This will become I. How do you see? You guys getting used to the this formula? Okay, it's not hard. And then 2, yeah, we can cancel it. Okay, so like this one. So it is 2 plus minus 2 root 3i, and divided by 2. We can cancel. It's like this. The last step is to convert this way. Okay, so that's the last answer. Make sure you're not going to write I inside. Okay, so I is still the outside. Therefore, the way that you need to respond to the examiner or respond to the question is that you need to finalize the question. How do you do it? Write the final answers like this. So a lot of people forget about this. You need to, okay, your answer is this or this whole lot. Okay, understand that there? Understand this one, everyone? So everything's okay, but you can always use this negative 1. Okay, square root of negative 1 is I. So that's the new thing. That's a brand new thing from this topic. Okay,